All right, so as long as you can see this, we should be good to
Yeah.
go. Okay, so I am going to do a two-part culminating. And yeah, so you can submit this any way that you want to. And I just assume that you might do it on paper, like you might have it drawn up on a computer monitor in front of you and just do it on paper and
Yeah.
take a picture of your work. But you can do it like you said, if you want to share a Google Doc or if you want to do it digitally, where you can, if you could write in
Yeah.
something here, then you're more than welcome to do
See, I
that.
find that easier because it's like you're not looking between your screen and your paper. You just
Yeah,
have one.
yeah, I would get that. I prefer just to kind of have it all in one for sure.
Yeah.
All right, so we'll go through it. So this is on the culminating. There's a little bit of everything. So, for example, in this case here, yours would say Antler on it, and I've changed. This is my basic one where I kind of fill in. So this person's name is Code. All right. So just like you, Code has recently taken a job at a pet store on Thoraldstone Road in Niagara Falls called Code's Paws, or How I Learned to Stop Worrying and Love My Pet Rooster. So on Code's first day, a cat named Lorem Ipsum. I don't know what your cat name is, but it's not Lorem
Cat
Ipsum.
Damon.
What did you have?
Cat Damon.
There you go. That's a pretty good one, I think.
Yeah.
So it's brought in and weighs 6 pounds and 10 ounces. So the cat requires some medication. So if we recall that 1 pound is equal to 16 ounces, what is the weight of the cat measured in ounces? So this is a ratio. Basically, it's like this. So we have 1 pound over 16 ounces. Or we could have put it the other way around.
Yeah.
Or we could have said 16 ounces
16 times 6.
to 1 pound. Yes. So.
It's never mind. Sorry.
Yeah, and so you could do it if we had six pounds. Mine's 6 pounds and 10 ounces. So if I want to know it just in ounces, right? So yes, I'd take my 6 pounds times 16, and I would get 36 plus 6, so 96 ounces.
And then add 10.
Plus my 10, and so I have 106 ounces.
Yeah.
And that's really important because I would want to figure out how much medication to give it. And we'd notice that on the chart on the wall, it says 3 ounces is equal to 85 grams. How many grams does a Lorem Ipsum cat weigh? So again, if we know that 3 ounces is for every 85 grams, right? Now, this goes back into my equation thing where I want an answer and I want it to be in grams. Right? So, and I'm given that I have 106. So I have 106 ounces. Now, I want to get rid of this ounces kind of thing, right? So if it's in ounces, that means that I want ounces to be on the bottom right here.
Yeah.
Okay? So in this case here, I could have done 85 grams to 3 ounces. And this is the one I want. That's the one I'm going to put in there because that one has grams on the bottom. I want the grams to be on top because the ounces will end up canceling each other out. So this is going to be 85 here, and there's going to be a 3 there. So now I need to do a little bit of math. 106 times 85 divided by 3. That should give me my grams. So I'm going to do that really quickly. And I got 3,003.3 grams. All right. So now I've got the weight in grams. So if Code is supposed to give Lorem Ipsum 7 drops of medication for every kilogram of weight, how many drops will Lorem Ipsum need? Well, I know that 1 kilogram is equal to how many grams?
Was it 1,000 grams?
Correct.
Yeah.
1,000 grams. So if my my cat Lorem Ipsum weighs 3,000, just over 3,000 grams, so that's right. So 3,003 grams is equal to 3.003 kilograms.
Yeah.
Therefore, I do 7 times 3 kilograms, because there's 7 times 3 is equal to 21 drops.
Okay.
All right. So my cat gets 21 drops. Now your cat, you might have a skinnier cat or a fatter cat than the one I have. So
Yeah, my cat weighs like, what was it? 3, 3 point something, but I was just wondering, like, what you do with, like, the 0.145 grams.
I would just round down. So if it's like, let's say it was 4.1 grams or kilograms, assume 4 kilograms at that point.
Okay.
Okay.
So, like, 3.1 grams could just be 3 kilograms?
Yeah.
Okay.
All right. So let's move on. Old Man Berryman, the owner of Code's Paws, sends Code to recover a bird, Pikachu, who has flown away from the store. Code is pretty sure that Lorem Ipsum scared away Pikachu. I mean, because birds tend to be scared away from cats. So, after many hours, Code finds Pikachu in Fairview Cemetery. Returning to the pet store requires walking 800 meters north on Stanley Avenue and 900 meters west on Thorlestone Road to get back to the shop. By the way, I think I deserve a lot of huge cred here for throwing so many Niagara Falls references in.
I know, it was, like, all accurate.
So,
Wait, do you live in Niagara Falls?
no, I don't. I live in St. Catharines.
Oh, wow. So you actually, like, had to do random places.
Yeah, I just pulled up a map and I have one of these already that I had set up for Welland. It just I changed it for Niagara Falls, so I just grabbed the map and changed some of the street names. So it's really not that big a deal, but I like to just pat myself on the back. So anyway, so we walked 800 meters north on Stanley Avenue and 900 meters west on Thorlestone Road to get back to the shop, which conveniently is really close to the McDonald's. So when Code gets back to the shop, Old Man Berryman wants to know what angle and how far Pikachu flew to get from the store to the park. So far Pikachu flew, so we want to know this distance right here.
Yeah.
Right? We want to know that distance. And we want to know what angle that Pikachu flew from. So Pikachu flew from this direction here. Right? So let's find this angle there. So let's do the distance first. So I have 800 meters I did on Stanley.
Yeah.
And I did 900 here. How would I solve for D?
You would do 900 squared plus 800 squared, and then get the square root of that, or whatever.
Exactly. So D squared is equal to 900 squared plus 800 squared. Very good. So I'm just going to use Pythagorean theorem. So 900 times 900 plus 800 times 800. So I'm going to take the square root of 1,450,000. And D is equal to 1,204. And it's in meters.
Yeah.
All right. So now I figured out the distance. Now I need to figure out the angle. So how am I going to figure out the angle?
So first you would, like, label the sides.
Yeah,
so
let's do that. What's the
D
one?
is hypotenuse.
Yeah.
The 800 is the adjacent.
So this one's the opposite.
Opposite, yes, sorry.
Yep, no problem. And then that leaves that one as adjacent. So it doesn't really matter which side you want to use because we know all three sides, but we are going to use SOHCAHTOA. And I would assume, let's use the 800 and 900. So if we want to use 800 and 900, so we're going to use opposite and adjacent. That means we're going to be using tangent. So tan of theta is equal to O over A. And so we have opposite is 800, adjacent is 900. All right, so when we do that, we get a value. which is a decimal. Looks like this, 0.889. I'm going to round off there.
Mm-hmm.
And then I need to know what theta is equal to, though. So I have to do this thing on my calculator, the one with the -1. Because that number is just a ratio. So I do second function. And tan. And I got I'm going to say 42 degrees.
Yeah.
All right, so I found that. So I got my two answers. I got my distance here, and I've got my angle.
Oh, wait, but is that the right angle? Because we're looking for the angle in between adjacent and hypotenuse.
Yes, so Old Man Berryman, I was asking the angle that the bird flew to get to the cemetery, right? So I just decided, I just picked this angle. It's kind of debatable which one you would normally take, but in this case here, as long as you kind of show me the work and how you got there. So I picked this one. Yeah, because this angle, the opposite and adjacent are relative to that angle that I've done there.
Okay.
Okay?
Yeah.
Have we hit the question that you had a question about?
Yeah, that question was the one with the what do you do with the point?
Okay.
Something in the graphs.
All right. If you have more questions, keep them coming. Or if something's not clear, just again, chip right in there and let me know.
Yeah.
All right. So Code has a coworker named Archibald at the pet store. Archibald attends Stanford Collegiate and struggles with his math class there. So Code agrees to help Archibald with his grade 10 math homework, having paid extra attention in Mr. Johnson's class, because who wouldn't? Duh. Right? So the first question of Archibald's homework says this. Complete the following table. So we need to find the sine ratio, the cosine ratio, and the tangent based on this angle right there. So
Okay.
how are we going to do that?
Well, we could take that old paper.
Yeah, if you have that paper, you could use that ratio table.
Let me grab it.
So yeah, there's the one that I had all the ratios on it.
Not being organized really turned out to help. Okay. So the sine is 0.500 or just 0.500.
Yep.
And then the cosine is 0.866.
Good.
And then the tangent is 0.577.
All right. Awesome. What about the other way around? What if we're given a sine value, but now we need to figure out what this is?
You could do second function sine equals 0.839.
Yeah, you could definitely do that. So it would look like this on your calculator.
Or I guess you could also use.
And likewise with these other ones here, you could have done.
Yeah.
You could have done something similar here. You could have just gone like this. You could have gone and just put sine of 30 degrees, and you would on your calculator, and you would have got this.
Yeah.
And same with here. You could have done cosine of 30 and tangent of 30.
Yeah.
All right. So what do we get if we did sine? Or if you looked on your ratio table, you could look at the ratio table for sine.
Yeah. Sine of 8, 7. You would get 57 or 56.
Yeah, 57 is going to be your closest one, basically. So we have 57 degrees. Now, once you have this one right here, then we can go back and do this one. So we could find the corresponding cosine for 57 degrees.
57. So the cosine would be 0.545.
Very good. I like that you even rounded it to the right number. Perfect.
Yeah.
And we'll do the tangent as well.
The tangent, I'm just gonna look on a paper 1 sec. 1.540.
Very good. Awesome. And again, you rounded it off to the right number, which is perfect. All right. Yeah, I'll leave the last one there because I think you guys know how to probably go like that.
Yeah.
All right. What about this one here? So the second question of Archibald's homework says this. Find the point of intersection between this line right here and this line right there. What do we do when we're trying to find points of intersection?
You're gonna put like everything to like one side, I think it was.
So basically, these are two equations of lines, right? When we're trying to find an equation of an intersection, we're actually trying to find where those two lines crisscross, basically. So to do that, all we have to do is let equation 1 equal equation 2.
Yeah.
So,
so you would get rid of the y's, right?
exactly, y is equal to y. Very good, exactly. So I'd go like this. Negative 2x minus 13 is equal to 1x plus 2.
Yes.
And now I am going to solve this. So I want to get all the x's to one side. So I'm going to subtract the x there. And whatever I do to one side, I have to do the other side. So I'm going to be left with negative 3x is equal to, and then this negative 13, I want to get rid of that. So I'm going to add 13. And whatever I do to one side, I have to do to the other side. So 2 plus 13 is 15.
Yep.
So these cancel out, and these cancel out.
And then we have negative. So negative 3 equals 15. Negative 3x equals 15.
Yeah, so how do I get rid of that negative 3?
You're gonna add 3.
So at this point, we've separated the sides, right? Once we separate sides, once we have all the x terms by themselves on one side,
Divide it by itself.
yeah,
Both of them
exactly. Very good. Divide both sides by the same, right? So we have negative 3 divided by 3, or divided by negative 3, is just 1.
So that gets rid of that.
Yep, and then x is 15 divided by negative 3. So 15 divided by 3 is 5. And since this is positive up here, a positive divided by negative is negative. So now we have a value for x. When we have a value for x, we need to find y now.
Okay. I forget how you find the y, I think.
So to find y, we sub in our value for x into either equation.
Oh, right, because y equals negative. Okay.
All right, so I'll pick either equation. I'll pick the second one, y equals 1x plus 2.
Or y equals 1 times negative 5 plus 2.
Exactly. So that's the end result there, right? So it's negative 5, that's right there. And then plus 2. So y equals negative 5 plus 2.
So y equals negative negative 3.
Very good. And that's it. So we have the 2 points now. And so we take a summarizing statement, and we would say, therefore, the point of intersection is at. So therefore, the point of intersection is, and we put our x value in, -5, and then we put our y value in, -3. And again, so your equations will be different from mine. So you will have a different point of intersection, but the process is the exact same.
Yeah.
All right. Now this is a reference to the greatest feline basketball movie ever made.
I remember that movie. Air Bud or something?
Yeah, Air Bud, you got it.
Oh, I loved that movie.
All right, so Coach Paw sponsors a local basketball team, and last year, obviously, you have to have a great animal. In this case here, I have Max the dog. You have, again, probably a different dog name. But so the ref checked the rule book, and there's no rule against it having to be human, so Max was allowed to play, just like in the awesome movie Air Bud. There's also one about a monkey playing called Most Valuable Primate, MVP. Anyway, so as you can see, Max is a perfect jump shot and helped to lead Coach Paw's patrollers to the state championship last year. Even though, so anyway, they were sadly defeated by Pet Center Transit Authority, and that was a rival one from St. Catharines. So, what shape is made by Max's shot as it travels through the air? What shape is this?
A parabola?
Yeah, that's neat. That's the easiest one, right? So this is obviously a parabola.
Yeah.
Easy mark right there. All right, so Max's jump shot reaches its maximum height, no pun intended, or we would call the vertex, right, of 24 feet when it is 19 feet from its shooting location. So you have a height and you have a distance kind of thing, right? So if you're looking at it like this,
Okay.
right? And so distance is our x coordinate and height is our y coordinate, basically, right?
Yes.
Okay. So write an equation that models Max's jump shot. So this comes back to our equation of a parabola using vertex form. So vertex form is y equals, do you remember the rest of it?
Y equals, I always forget the numbers.
Always the letter A. Always the letter A first.
A. Oh, A, B, X, M, something.
So this part is where it gets kind of confusing.
Yeah.
It looks like this. Like that's our vertex form.
Yeah.
All right. So if we were to write an equation, and here's the ball falls this. This information that's given right here, that's how far down it goes as it travels 1 foot further. That's our step pattern.
Yeah.
All right, so our step pattern, that's our A value, right?
Yeah.
Okay, so if we look at our equation then, so y equals, now is our parabola going down or up? Which way is it opening, up or down?
Down.
Down. So should it be positive or negative, the step pattern?
Negative.
Correct, it is negative. So that this, we put our step pattern value in here, negative 0.091, and then we have to put our information in here in our vertex form. So if you recall, in vertex form, we were given these two things correspond to our vertex. Except one slight problem. X is a liar. So the value that we have in this spot right there, right, is the opposite. So if we think about this, like if we think about this as a graph, right, and the vertex is right here, and we know that this coordinate on mine is 19 is my x value, and 24 is my y value. Right, because this is 24, and that's 19 right there. Okay, so if x is 19, so it's the opposite of that, right? So it's positive 19, so here it should be negative 19.
Negative. Yeah.
Okay? But y never lies. Y is whatever it is. So if y was 24, then it just stays plus 24. So that's my equation.
Okay.
Right? That's the equation of Max the Dog's jump shot. So then we could find the equation, and actually, don't worry about this. I was actually supposed to have a thing that's supposed to put in a distance value, but obviously I'd screwed up and I didn't put it in there. So don't answer the last question.
Wait, what question do we not answer? C?
Yeah, because this is
All
supposed to be a value, but I messed up and it didn't insert a value.
right.
But don't worry about that. So that's it, except for the last part, which says, in this case here, we could draw a photo of Max next to Max Jr. with Pikachu. So Max Jr. is not in this because I removed that question, but with Pikachu on his shoulder. And that would be difficult, and my drawings would be pretty bad. So in any case, that's how you do this first culminating.
Okay.
All right? So the numbers that you have will be different, but generally the questions are the same idea.
Mm-hmm.
So follow that same process, and you should be good.
Okay.
Do you have any other questions?
Yeah,